about thermal cameras today, give you an idea. My name's Andy Baker, I'm the UK Sales Manager for FLIR Systems. FLIR Systems is the world's leading manufacturer of thermal imaging cameras. Last year we sold 3 times as many thermal imaging cameras as all the other manufacturers put together. We have 2 main divisions within the company. We have our military division, which sells cameras to the police and to the military. These tend to be non-temperature measurement cameras. You've probably seen them on the police camera stop type programs with the helicopters when they're following the crooks either on the motorway or through the back gardens at night. I work for the commercial systems division, and we make cameras that can not only see what's hot and what's cold, but can accurately measure exactly how hot or how cold an object is. In the UK, at our head office down here in Kent, we have a full calibration, repair and service backup. And 18 months ago, FLIR Systems made the decision to go away from selling the bulk of their cameras direct to a 100% distribution approach to sales. So Alpine Components has been for many years one of our top distributors, and we hope they will continue to be so in the future. What I'm going to do for you this afternoon is just give you a basic introduction to infrared theory. Going to look at some industrial and some building applications, and then I'm just going to run through some slides on our brand new E-series cameras and show you some of the features and specifications that make these a really good standout series of cameras. Okay, so let's start with a nice steady introduction to infrared. So what is infrared radiation? Well, everything around us is emitting infrared heat or energy. That energy is being emitted in the invisible part of the electromagnetic spectrum and cannot be seen by the human eye. So if you look at the spectrum here with where my mouse is, our eyes are typically seeing round about just under the 1 micron mark. Thermal imaging cameras are detecting energy typically between 3 and 14 microns. When I first started selling cameras 10, 15 years ago, the bulk of the cameras that we sold in those days were short wavelength cameras, and these detected energy between 3.5 and 5 microns. The downside to these cameras were that you had to put either liquid nitrogen or use a Stirling engine to cool the detector down to cryogenic levels so it saw the objects in front of them as being much warmer. In the last 10 years, there's been a complete swing around, and I would say that 99% of the cameras that FLIR now manufacture are what are called as long wave thermal imaging cameras, and these are detecting energy typically between about 8 to 14 microns. And the advantage of working with these cameras are that the detectors that we can use in these microbolometers have inbuilt sensitivity. You don't have to falsely create it by putting liquid nitrogen or anything like that. So you can switch the cameras on, they're ready to use in a matter of seconds, and apart from holding the detector at a stable temperature, similar to the inside of your fridge temperature, the cameras are ready to go. So that is where most of the sales goes these days. So what does a thermal camera do? Well, a thermal imaging camera converts invisible infrared radiation into an image or a thermal picture that we can see and understand. So here we've got a couple of examples. We've got a building on the outside here, and we've got some electrical switchgear on the right-hand side here. So infrared thermography is the science of acquisition and analysis of thermal information from non-contact thermal imaging devices, because we don't come into contact with the objects that we're looking at. We point the cameras at them, they're throwing off infrared heat or energy, and we're building that up into a 3D map or profile of what we're seeing, whether we're looking at the outside of a building for where energy is escaping, or whether we're looking at electrical, mechanical components for hot spots, which indicate that there may be issues which could lead to fires and things like that. So this is a basic thermal image. This is what the military work from. They work in black and whites, and they don't have any temperature measurement. In our commercial systems side, the first thing we do is add a temperature scale to the thermal image, and then we add colour. So now when we're looking at this image, I think you get a very, very nice clear thermal image here. We've got a 3-phase supply coming in. The 2 outer phases are around about the 50-degree mark. The centre phase here is up over 66 degrees C. So we can see quite clearly that there is something starting to happen here. And that's the whole thing about the cameras that we sell. Not only can they see what's hot and what's cold, but they can accurately measure exactly how hot or how cold the object is. So it's going to allow you to make decisions as to whether this is a critical problem that you need to effect an immediate repair to, or whether there is a small rise in temperature and you're going to continue to monitor that item over a period of time until it reaches the point where you decide that you need to do something about it. So why do people use thermal imaging cameras? Well, as you've seen from the basic images that I've put up so far, a picture speaks 1,000 words. It's very, very easy and very quick to see exactly what you're looking at, and you can quickly identify specific areas of urgency, as I mentioned a few seconds ago. Also, very often you go out with the thermal camera looking at specific items, but while you're scanning around with the imager, you'll pick up other issues that you didn't realise were there in the first place, so secondary problems can be picked up. What you can also do with the cameras these days is you can store the thermal and often a visual picture onto the actual unit, bring it back into the office, and then put a report either into your manager, if you're a professional thermographer, to your customer that you're doing the report for, and even to an insurer to prove that work needs to be done, and when it's been done, that it's been done properly. But at the end of the day, people don't buy the thermal cameras because they're sexy and good fun to operate. They buy them because they save time and money. They buy them because it helps keep their production line running, it helps reduce the amount of energy that's been lost from their buildings, and they see that payback in cold hard cash. So that's the real reason that people go for these cameras. Okay, so that's giving you a small introduction to the theory of what we do. Let's take a little bit of a look at some applications. I'm going to start off with what we would call industrial applications. Maybe you may know them as predictive preventative maintenance, but we're calling them industrial now. So first of all, we'll start off with electrical. When I first started selling the cameras many years ago, 99% of the cameras that were sold all went into electrical and mechanical testing applications. And whether they were used looking at transformers, bus bars, switchgear, fuses, frequency drives, all these types of things where if you get loose connections, phase imbalances, things get too hot, they can eventually lead to a point where they will catch on fire. And it is a proven fact that the biggest cause of industrial fires in Europe, never mind the United Kingdom, is overheating electrical cabinets or components. So this is what we see with the human eye. When we point a thermal imaging camera at something that's got a fault, this is what we see with it. And this is what I like about thermography the most. These problems just jump out at you. You're not scratching your head wondering what's happening, is there anything there? If there's a problem, you'll see it. Now, all of these are what we would call poor or loose connections. So on this particular one, you can see quite clearly there's two, loose connection in this fuse, on this phase, going into this fuse here, and on this phase, and this was the one that I put spare here. So very, very clear, very, very simple. You're going to point the camera at the objects you're interested in. When you see where the heat's escaping the most, you'll put a temperature measurement device onto it and measure how hot is hot and decide how serious your connection problem is there. Very often now with modern thermal imaging cameras, when we store a thermal picture, we will store a visual picture to put alongside it, especially if you're putting that into a report, whether it's to a customer or even to somebody within your own company that's going to effect the repair. It does obviously help them identify the object. So here's what we see with the visual camera, and when we looked with the thermal camera inside this particular cabinet, we can see we've got one component here up over 115 degrees C. The ambient temperature was down at about 36 degrees C, so we got somewhere in the region of a 70-degree rise in temperature there. That was a critical problem, and that needed to have an immediate repair effected to it. So that was something that could quite easily have set this cabinet on fire. Just some more examples. This is another one that I took, just looking, pointed inside, quite a large cabinet, lots and lots of wires. This is what we saw with the visual camera, but you can see quite clearly here where you've got a problem with one of these connections. Now, another good thing about the modern cameras is there's a mass of wires in here. You can see roughly where this is. How would you help identify that exactly? Well, the cameras now have laser pointers built into them, and that would help identify exactly which cable it is there that needs the repair effecting to it. And you can see this cable here is up over 70 degrees C. A lot of the other things down here around about the 30-degree mark. This is another one of mine. was called into a company to have a look at some specific problem that they got. This wasn't it. This backs up the secondary fault thing. We were walking past this buzz ducting, and I just happened to point the camera at it, and I could see there was quite a warm spot developing on this buzz ducting here. So we snapped a thermal picture of it. The ducting itself was reading us about 36 degrees, something like that. When I left the plant, they stripped the outer casing of this buzz ducting and looked inside it. Underneath there, the actual temperature was over 100 degrees C, and that was a critical problem which they were very, very pleased we found for them. Now, this ties in quite nicely with something John mentioned earlier about infrared windows. What I should make quite clear here is that thermal imaging is a surface detection device. It doesn't see through cabinet doors, it doesn't see through buzz ductings, it reads the surface temperature. So what had happened here is the massive wires beneath that were generating enough infrared heat to cause a hot spot on the outside of the buzz ducting. Inside your electrical cabinets, if they've got interlocks or safety devices, which means you can't open them without cutting the power off, what you can get these days are infrared friendly windows which you can install into your windows. You can then point the camera at it and they will look through and onto the objects that are behind it that you're wanting to scan and look for problems with. Okay, so those are some electrical applications. As I said earlier, the other major area that we used to get involved in, or still very much get involved in, were mechanical applications. So whether we're looking at motor bearings, pumps, tank levels, refractory integrity, insulation integrity, there's a whole host of applications that you can use the cameras for in this area. So let's have a look at a few examples. So electric motors can be analysed for bearing and case temperatures, checking proper ventilation flow, and electrical supply connection problems. This is obviously quite a new motor in quite a clean plant, but very often motors are used in very dusty, dirty environments. If these cooling ports or fins start to get clogged, that can cause problems with overheating motors. Also, if the winding itself is faulty, that can also cause motors to overheat. So there's a picture of the motor showing quite clearly where the winding is, and coming out here is the bearing end, and we can see that this is getting very, very hot at this end here. Some more just general shots of motors showing here around this end here. Again, with the bearing, this is getting very hot. The motor itself is reasonably cool. On this particular one, all these three motors were doing exactly the same job and therefore should have been running at similar temperatures. We can see this one was running normally. This one was getting a little bit warm, but the one in the centre was much warmer than the other ones, and indeed there was a problem with the cooling fins being badly blocked on that, so they needed to be cleaned out so that the motor could run at a much more efficient temperature. Major use for thermal cameras is looking at bearings in mechanical applications. See a visual here of this particular bearing. This guy didn't want his bearings to run at much hotter than about 65, 70 degrees C. When we pointed the camera at it, you can see this one was actually running up at about 82 degrees, something like that. So this was something that he wanted to have a look at. Down at the bottom here, got two very nice images of shaft support bearings. What we've got here are two bearings with a shaft running through it that's rotating at high speed, and that's the same here. This bearing and this bearing here should be running at a very similar temperature. What we've got within this shaft bearing is quite bad misalignment, which is causing a lot of vibration in this end bearing, which is causing it to heat up much hotter than you can see on this one. And I think there was something like a 40 to 50 degree differential between these two bearings. Same on this one. This bearing here and this bearing here should have been running at similar temperatures, but because of shaft misalignment, this one was obviously getting much hotter. Now, you don't need a big amount of misalignment to cause quite a severe rise in temperature on these bearings, so it's again a very good and very quick way of picking out problems with bearings. Okay, this is another one of mine. I was invited into a company here. This was a manufacturing plant, and they were having problems at one end of the plant where product should have been passing through this and on to the next phase of the manufacturing procedure, but they weren't getting the volume through. So this is what we could see with our eye. When we put the thermal camera on it, we could see very nicely what was happening here, that there was big deposits that were clogging up on the inside of this, only allowing a very, very small amount of product to flow through this. So they were very pleased to see that. They understood what was happening. I believe they took the scientific approach after I left and gave it a smack with a sledgehammer, which seemed to effect the repair for them. So nice way of showing where you've got problems. Looking at hydraulic or water systems, here we can see this is the thing with a visual picture. Sorry about that. With a visual picture, they could see that they knew the hot water was getting so far, but they couldn't tell what was happening to it from there. And when we pointed the thermal camera at it, this confirmed that yes, hot water was coming through to here, but there was some problem with the valve which wasn't allowing it to flow on and continue into the system. So it very quickly identified for them that this wasn't the proper thermal pattern that they should have been seeing on this system. This is a nice one. This is a large oil refinery. I actually think it's the one down in Pembroke where there was the recent incident. What we're looking at here are level checking. I've put two of these up for you to look at. In this particular case, took the visual picture. You can see quite clearly this is winter, quite a harsh winter when we took this. And when we look at the thermal, what we're seeing is that because it's got a very, very cold background, minus 40, 50 degrees up in the atmosphere, what's happening is that the liquid in the tanks is appearing very warm, but the gas or air in the space above the liquid is being affected by the cold air temperature and therefore is showing as being much colder than the liquid level below it. When we move to summer, you see a completely different effect, because what's happening now, this was taken in summer on a nice warm day, there's a lot of sun falling on this tank as you can see from the visual, and what's happening here now is that the liquid in the storage tank is appearing as cold, but the gas or air that's above it has been heated up by the sun and is appearing much warmer than the liquid itself. So whether you're looking at these things in winter or in summer, the camera will give you a good idea of what's happening in your storage tank as to what sort of level of liquids that you've got inside there. Okay, so hopefully, excuse me, I do apologise. Hopefully that's giving you an idea of some industrial applications. Now, if you'd have asked me 5 years ago where did the bulk of FLIR's thermal cameras go, I would have said into industrial applications, electrical and mechanical maintenance. In the last 5 years, we've had a secondary application that's built up for us in the building industry. And for the last 4 quarters of FLIR sales, cameras into building applications have actually outsold sales into industrial applications. So that doesn't mean the sales of the industrial cameras has dropped off. They've continued to grow nice and steadily, but what we have seen is a massive growth in the sale of cameras into building applications. So we're going to have a little look now at some of the uses that the cameras are put into in these applications. What you'll see here is I'm using quite a few images courtesy of a company based up in Scotland called IRT Surveys, who specialise in offering the thermal survey service with our cameras. So here we've got a typical house, and when you're doing insulation or heat loss surveys on buildings, what you typically do these is between sort of October and March. You will start the survey typically an hour after sunset, so that any solar heat put into the building during the day will have disappeared. The house will have been heated during the day, and then where there is any lack of insulation, you will see where the heat is starting to escape around these areas here. So it's a very clear. What you also need to have when you're doing these surveys is typically a 10-degree differential between the inside temperature of the building and the outside temperature of the building for you to be able to see this. So we can see quite clearly in these areas where there is a lack of insulation. This is quite a classic one. See under the window here, very often people have insulation pumped into their walls to stop it going. It sometimes doesn't always get underneath windows or around the tops of doors where it should do, so that's a very classic place for seeing it. But again, you can see quite clearly, it's very simple to spot under the right circumstances, as I intimated earlier, where you've got insulation defects. Another classic use for the cameras is to find water ingress into flat roofs. It's very, very expensive to replace water damaged flat roofing, typically about £1,000 a square metre. So if you've got a very large flat roof with water ingress, rather than wanting to replace all of it, almost certainly what you'll want to do is patch repair where the damage has taken place. What you do, it's very similar to the way that you use the cameras when you're looking for heat loss on buildings. Same time period, October to March, during the day, the sun will heat the flat roof up to a nice, even, homogeneous temperature. As soon as the sun goes down, the dry areas, which are indicated in blue, will lose their heat very quickly, but the wet areas with water will hold on to the heat for a much longer period of time. So you go up with your thermal camera, you will see where the hot areas are, typically mark it out with a spray can, and then the next day you'll go back up, take some core samples just to make absolutely sure that it is water ingress, and then you can patch repair those areas and save thousands and thousands of pounds on your roof. This is moisture ingress on the inside of a building, and this was starting to cause local damage, and people want to do a fix to this to prevent more serious problems, because once you get water ingress, you can lead to the growth of mould and spores, which can be unhealthy to people's health. So this was in the corner of a building. There was a pipe that was on there leaking into the corner here, and on this occasion it's shown quite clearly as being cold as the water's coming into the building there. Quite often moisture ingress can be caused by a small leak. If you get something like a major flood, if you're near a river, or if you have a water tank that springs a leak on the top floor, you may find that you get moisture ingress in several areas of your house. Once you've done that, you're probably going to have to call in some sort of specialist company that are going to dry and get all the moisture out of your house. They use our cameras quite extensively, because what they want to do is identify the areas within the building where there's heavy moisture, so that they can point the dryers at them, and then they want to take that, have the dryer on that area for a period of time, and then point the camera at it again to make sure that it is doing the job that it's meant to do. Just coming back to secondary things, if we look at this here, we can see where the dryers have been heating this area of wall up here to try and dry it out. This is a back door on this particular building, and as well as drying it, I think they probably ought to look at a decent seal along the bottom here, because there's quite a lot of cold air coming in from the outside. Again, this was a canteen at a large factory, and they knew that they had got a leakage in one of the underfloor pipes. They didn't want to have to take the time and effort to take the whole floor up to find out where this was. So we went in with the thermal camera, we pointed at it, and we can see where the pipe was going and where it should have been continuing to, and quite clearly here where it was getting warm, which was where the problem was, where the leakage was. So instead of having to take the whole of this floor area up, they could do it to maybe 2 or 3 tiles to effect a repair. And not only is this now being used in industrial applications, but also in domestic ones. If you've got a very expensively tiled bathroom and there's some sort of underfloor leak that you've got there, you don't necessarily want to have your tiles taken up in the whole floor. So more and more plumbers are investing in some of our entry-level cameras, and they can come in and they can find out where the problem is and just effect a repair without having to rip your whole bathroom floor up. This was outside. This was leak detection. This is a pavement here, and you can see that this was a roadway at a large manufacturing plant, and there was a leaking heater pipe. Again, it would have been very costly for these people to try and rip all this area up to sort of find out exactly where it was. So using the thermal camera here and here, they helped identify exactly where the problem was. So they localized in on the problem rather than guessing and digging a whole area up, which would have cost them an awful lot of money to put back again. This was quite an interesting one. We were called into this particular office block, where the people that were normally working in this area were complaining that they felt cool and sort of damp even when it was summertime. They weren't comfortable in comparison to other areas, So when we pointed the camera at it, this is the window here, and there's the window there, and we can see they got a heck of a lot of moisture that was coming through there that was giving them that phenomenon that they were experiencing. First thing they needed to do was to cure the seal around the window, and then they brought in the moisture company who blasted the fans at it to take the moisture out of it, and we checked it again afterwards, and that solved that problem. Not only in industrial buildings but also in domestic buildings, more and more modern ones are going away from radiators to underfloor heating. Now, sometimes you have to, when the floor's been put down, you have to drill to put some installations in. There may even be a fault with the underfloor heating. This is what you see with your eye. How do you work out where it is? Well, the camera's excellent at that. We suggest that the heating's switched off before you arrive with the camera. Switch the heating on, and most of the underfloor heating, whether it's tape or water pipes, is sinusoidally wound up and down. You'll see within a matter of minutes, as the heat starts to go through the pipe, you can follow it until A, you find out where the breakage is and effect a repair there, or let it get to a point where you can see where all the heating pipes are, so that if you're going to drill to put something in, you can drill without going through the water pipe or the tape and causing problems with it. Okay, so that's given you quite a nice overview of, first of all, the industrial applications that we use the cameras for, and also the building types of applications that the cameras are used for. What I'm going to do now is just briefly run through for you the FLIR E-series range of cameras. This was a camera range that was launched in Q1 of this year, and it's got some very unique and innovative features built into it that no other cameras have out there. I just wanted to take the opportunity to tell you a little bit about it. So, before we go out and develop a thermal imaging camera, what we like to do is talk to the people that use them, our customers, and get some sort of input from them in what they would like to see in a thermal imaging camera. And what came out for this centre segment range of cameras was, what was most important to people was to have something that was very easy to use, point and shoot is what I like to call it. It needed to be price sensitive. It needed to be highly portable, small, light, built-in battery, yet they still wanted good imaging performance from it. They didn't want something that they were scratching their heads, working out to try and work out exactly what they were looking at. So what we wanted to do was create a new class leader in what we would call this gun class type of thermal imaging camera. And we reckon there's about 20 to 30,000 units of these sold worldwide. We wanted to make it small, light, yet still of an appealing industrial design. We wanted to make it rugged. We wanted to give it a nice compact expression. We wanted to give it a really nice increased feeling of value for money. We wanted to include fantastic image quality, and you incorporate some of the most modern types of touch user interface that you get with other modern equipment that people use on a daily basis. So what sort of functionality did we build into this? Well, I'm not going to read all these out to you. I'll let you just have a sort of look at some of the things that's going on here. But cameras going up to 320 by 240 pixels, high temperature ranges, 50 millikelvin, so very, very sensitive, fast frequency, so you can look at mechanical components, a very high resolution visual camera, you can do manual focus with it, it's got touchscreen interface, it's got Wi-Fi interconnectivity, it's got Bluetooth interconnectivity, all sorts of things that we wanted this camera to be able to do. And this is what we came up with, the E-series thermal imaging camera range. There's 4 cameras in the range. The detector size goes from 160 by 120 through to a mid one of 240, 180 up to the very top end of 320, 240. They've got fantastic sensitivity, around about 50 millikelvin, which is 0.05 of a degree. 60 hertz, it's IP54, so it's very rugged. You've got a nice large display to view the image on with touchscreen interface, manual focus. It's got LED lamps built into it. It's got a tripod mount, laser. You can store Bluetooth voice annotation, text, the zooms. It's got Wi-Fi, Bluetooth, all sorts of things that you've built into this. So let's have a little bit look at these in more detail. So The two entry-level cameras in the range, the E30 and the E40, are 160 by 120 detectors. They are 170 millikelvin sensitivity and they have a 25-degree field of view. The middle camera in the range, the E50, has a larger detector, 240 by 180. It's 50 millikelvin sensitivity and has a similar field of view. The top of the range, the E60, has a 320 by 240 detector, 50 millikelvin sensitivity and has a 25-degree field of view lens. We wanted to be working with the very latest wireless communication, so we built Wi-Fi into these cameras, so you can get images directly onto a mobile device like an iPhone or an iPad, which is running a FLIR viewer application, which means in the field you can upload images directly to your iPhone or to your iPad to send them to other people that they can view them. You're out in the field, onto your phone, email to someone else, they can even give you a second opinion of what you're looking at when you're working out in the field. And we'll touch on Wi-Fi a little bit more in detail later. We want to make it easy to perform your infrared inspections easily and share your findings easily. So the FLIR series camera with FLIR tools, the iPhone and the iPad app means that you're going to be able to do all these very quickly and very efficiently. FLIR also own a company called X-Tech Instruments, who manufacture a range of test and measurement equipment, and what we've built into these cameras is the ability to link a X-Tech clamp meter or an X-Tech moisture meter directly to the camera, so that if you're using it for electrical maintenance and you find a fault, first of all you can store the thermal image showing the temperature rise, then you can put the clamp meter on it, get a reading from the clamp meter, and you can Bluetooth that reading directly onto the thermal picture, so that you're not only storing the picture with the temperature reading, but you've also got the clamp meter reading as well. Same for moisture. If you're using the cameras for building, if you're finding moisture ingress, you find an area that's got moisture ingress, start the image, put the moisture meter onto it, and it'll tell you exactly how wet is wet, and you will store that with the thermal image as well. Okay, how are you going to view the picture when you work in the camera? Well, we've got a nice 3.5-inch landscape LCD. It's a transmissive LCD, which gives better visibility both indoors and outdoors without having to use a sun shield. And with transmissive LCDs, it's also a much lower power consumption, so you're going to get better life out of your batteries. What we really wanted to build into this, once we decided we were going to go for Wi-Fi to link to your iPads and iPhones, we wanted to have the same sort of functionality as those very commonly used pieces of kit. So we've gone for a touchscreen LCD on the back of it, which means although there are still the normal buttons that will allow you to drive the menus, you can now operate all the menus, move spots, resize a box, adjust thermal isotherm level directly on the touch screen on the back of the thermal camera. And we found that this is a really, really nice way of people operating the units. We wanted to keep it nice and easy, so we give large backlit buttons for those of people that like to still operate them through the buttons rather than touch screen, or if they're going to be using gloves or a face shield. And the touchscreen interface is very intuitive, very easy to use, and I find it very efficient. For 20 years now, I've been using buttons to work my way around the camera. I hardly ever touch the buttons now. I just use the touchscreen. It's so much easier to operate the camera with. When you store an image, what we wanted to do was give you the capability to store data and identify and group everything together all in one app. So when you store a thermal picture, it will automatically store a visual picture with it. If you decide that you want to store some voice comments with it or text comments, it will store all three together in one file, so that when you come to pull these up back from the camera, you're just going to one location to get all this information rather than having to pull it from different places. In our top-end camera, the i60, for those people that want to actually do an instant report when they're out on site, maybe this is a thermography professional who offers a thermal survey service, there is even an instant report built into the camera. So he's found a critical fault on site, he wants to give a there and then report to the person who's doing the survey for, he can actually do that. He can deliver a PDF report directly on site. What we've also built into this range of cameras is the ability to change optics. As you saw from the slides earlier, they all come with a standard 25-degree field of view. If you're going to be doing some distance work, you can take that lens off and put a 15-degree telephoto on it. If you want to see more, maybe specifically if you're doing building work, you want to see more of the building in your shot, you can take your standard lens off and put a 45-degree wide angle on. The range of cameras that this E-series replaces just had a standard built-in lens. So again, we are upping the functionality that you can do with this series of cameras. So just to confirm, for industrial applications, we have the 30, 40, 50 and 60 with these size detectors. What we've also done are specific building versions of these cameras. So there's a 330BX, 40, 50, 60 the same, and the B stands for building. Just 1 second. There we go. Oh, didn't like that. Bear with me, guys. Sure what's happened there, guys. I'm very happy. Okay, let's try again. No. Okay, sorry about that. So I don't know if the machine went into slow down or something. So just quickly to show you there, these are the differences between the cameras again. Not going to go down these for you. What you'll see is that there is an upgrade as you go up the camera range of what you can do with it, extra sensitivities, additional features built into it from the entry level up to the very top of the range camera. What's different in the building models? Well, we've narrowed down the temperature range. The industrial models go up to 650. These tend to top out at about 150 degrees C because you don't tend to see much above 150 degrees in a house. We're giving you a better sensitivity or noise equivalent temperature difference, and we're putting in a couple of specialist features for the building industry. One's a moisture alarm and one's an insulation alarm to show you where you've got areas of moisture in your building or where there's insulation deficiencies. What do we see as lookout specifications for these cameras? Well, nobody else has got meter link, nobody else uses a 3 megapixel visual camera, very few have laser point alignment, nobody's got Wi-Fi, nobody has instant report, and nobody certainly has the iPhone app that we can offer at the moment. So if you're going to want to use this with your iPhone or your iPad, there is an app that you can get. There's one free of charge, one that's slightly more expensive. If you want to do a little bit more work, we'll cover that in more detail, but these are available now. You can go to your supplier of these and you can download the app onto your phone or your iPad. And what this is giving us is what we would like to think of as seamless integration. When you're out on the field, you can store your thermal pictures and Bluetooth the clamp meter or the moisture meter reading onto it. Once you've got that there, if you want to get that information out to somebody very quickly, you can Wi-Fi it to your phone or to your iPad, which have got the apps installed onto it, and get it back to somebody very quickly. This means you're going to be able to take real-time decisions while you're out in the field. Information can be sent, read, and decisions can be made in real time. And also, obviously, what it's going to allow you to do is to share critical information with other members of your team or staff immediately to show what you're finding when you're taking the thermal measurement readings. As I mentioned earlier, there's two versions of this. There's a free one, which is what we would probably call a viewer. It will just allow you to have a look at the images that you've uploaded from the camera. If you decided you want to go for the pro version, that will give you some measurement tools, it will give better file sharing features and also much better reporting features. And it costs about 20 quid for the pro version. Okay, I've probably gone a little bit over the half an hour. Thank you very much all for your patience there, going through the applications and then the cameras. My experience of webinars is that these are a fantastic medium for transmitting information over to people. They're not the best way of having two-way conversations, especially when you've got 50 or 60 people sitting in on them as we have today. So what I would recommend is that if you have any questions or queries that you want to take up from the presentation, you either give John at Alpine an email or give him and his team a call to go through any of the questions you've got, and they will be happy to help you out with it. I just want to thank you all again for your time and patience with me this afternoon, and also for John at Alpine for setting this this webinar up.
Well, thanks very much, Andy. I thought you did a really great job there and covered all the applications really well, and also the new cameras. So just to confirm, obviously we've recorded the webinar today, so we're going to put that onto our website in the next hour or two, and then we'll send you all an email so you have a link to that and you can share that with your colleagues, anyone who couldn't attend today. And then obviously you can come back to me with any questions, and I can obviously speak to Andy if there's anything I can't help with. And if anyone wants to see any of these cameras or talk further, then obviously you can get in touch. I don't think we had any real questions to answer at the end here, Andy. There were a couple of things. Well, actually, I say that. There is one question. Can you advise on training courses for the level 2? We absolutely can. I'll ask my colleague Chloe, Antonio, just to come back to you with some details on the level 2 thermography courses. But unless there's any other questions, we will send you that email. And thank you very much for your time, and thank you, Andy, for doing a great job today.
Thanks, everyone. Bye.
Thanks very much. Bye-bye.